All right, so in class this week, we reviewed square roots because the topic we're going to be moving into here probably by next week is going to be the Pythagorean theorem, which really relies on squaring numbers and finding the square roots of numbers. So I thought it was important that we reviewed the basics of finding the square root of a number. So what is square root? It is the opposite of squaring a number. So if you remember that squaring a number is multiplying that number by itself. So for example, down here we've got 4 squared. Really means 4 times 4, which comes out to 16. So the square root of 16 is 4. The square root is whatever number was multiplied by itself to get 16. In this case, 4. All right, so that's what the square root is. And the example here, the 16 is called a perfect square because when you find the square root of it, it's a nice even whole number. Finding the square root of a number is, it's basically division. So whenever you're dividing a number, if you can't divide it evenly, you can get some sort of a wacky rational number like a decimal or a fraction. Well, the same thing can happen whenever you're finding the square root of a number. And very often you'll come up with some irrational numbers that are just like random decimals that go on and on and on and on forever. Some common perfect squares are like the square root of 25, which is 5, the square root of 16, which is 4, the square root of 9, which is 3, and so on and so on. So any number that can just be square rooted to a nice round whole number is called a perfect square. So how do you find a square root? One way is to use a factor tree. So in the example I'm showing you here, if you wanted to find the square root of 16, the first thing you could do is go through the prime factorization of it. So 16 can be factored down to 2 and 8, 8 can be factored to 2 and 4, 4 can be factored to 2 and 2. So the prime factorization of 16 is 2 times 2 times 2 times 2. So we would write that in our square root box. So the square root, what we have is the square root of 2 times 2 times 2 times 2. Then we could identify pairs. So we've got a pair of 2's here, and we have a pair of 2's here. All right? And we would write those pairs in their own square roots. So we could say that the square root of 16 is actually the square root of 2 times 2 times the square root of 2 times 2. Then we would find the square roots of those pairs. Well, since the square root is whatever number times itself gives you that number, so like the square root of 2 times 2, believe it or not, is just going to be 2. And same thing over here. So what we come up with is 2 times 2. We multiply together to get 4. So we go through all this long process to find that the square root of 16 is 4. That's a lot of work, and I honestly don't expect my students to be doing that, but I show it to them anyway. I'm going to be letting my students use a calculator more often. So in most scientific calculators, like the ones we use in class, are the TI-84s, which I don't have one of those on my computer, but I can just show you right here. You would press your square root button. Well, on the TI-84s, you press the square root button first, you press the number, you press enter. Here on my nice little computer calculator, if I press the number first and then hit my square root box, it's going to automatically give me the answer there. All right, so students will be allowed to use their calculators in class. This is just something that I thought it was important to reinforce before we get into the Pythagorean theorem, which is a lot of fun.